Good morning. Happy Wednesday. I want to start out by saying how much I miss each of you, and I hope that you and your families are staying very healthy. Can't wait until we can be back together in the classroom and I can hear all about the good news that each of you have. So, when we last met, that was Thursday before spring break, we started our unit on solving systems of equations, and we did our first section on graphing. When we graphed the system, we saw where the two equations overlapped, and where that point was, where they overlapped, was our solution. That method sometimes can be tedious, and in addition, it can also be hard because if your two lines don't intersect at a point that you can visibly identify, then it's something that you would have to have a guess for, and you would not have an accurate answer. So today we're going to look at another method, which is substitution. We're going to solve some systems, and we're also going to solve some word problems where we will create our two linear equations that make our system of equations. So there's some steps here, 4 steps for solving linear equations using substitution. The first thing you want to do is make sure that one of the equations in your system is solved in terms of a variable. Once you do that, you'll take and substitute what that expression is for that variable into the other equation. When you do that, you'll be able to combine your like terms, simplify, and solve for one of the variables. After you do that, you will then, in step 3, substitute that value back into step 1 and solve, and that will give you the values for both of your variables. You can always check your solutions by substituting each value in for the variable and making sure it is true. So let's actually do some practice now so it makes sense of what I'm trying to tell you in words. So our first system is m equals 4n and 3m plus 2n equals 28. So step 1 says to look and see if one of your equations is solved in terms of a variable by itself on one side with nothing but that variable. I look and I notice that my top equation I have m by itself on the left and it's set equal to 4n. I'm going to take what m equals and I'm going to plug it in. I'm going to substitute it in for m. So 3 instead of m, I'm replacing or substituting it with 4n plus 2n equals 28. 12n plus 2n equals 28. 14n equals 28. I'm going to divide by 14, and n equals 2. So now I know what n equals. Now I substitute again, but I'm going to take and replace that into that first equation. So I'm going to have m equals 4 times 2. So m equals 8. We write our solution as an ordered pair alphabetically. M comes before n, so 8, 2 is the solution. And you can plug those in and make sure it makes each of those equations true to check your answer. The second equation is y minus 2x equals negative 17, and x plus y equals 16. Okay, so the first step is to look and see if a variable is by itself on one side. That is not true with the first or second equation, so you have choices. You can solve the first equation in terms of y by adding 2x, or you can solve the second equation in terms of x or y. It doesn't matter because both of them have a coefficient of 1 in front of them. So it's just a matter of which one you want to do. I'm going to take the second equation. I'm going to solve it in terms of x. So I'm going to subtract y from both sides. When I do, I get x equals 16 minus y. Now I have that equation solved in terms of x. I'm going to take what x equals, which is 16 minus y, and wherever there's an x in that other equation, I'm going to substitute. So this becomes y minus 2 times 16 minus y equals negative 17. I'm going to share the negative 2 to both the 16 and the negative y. So I get y minus 32 plus 2y. Two negatives make a positive, equals negative 17. I'm going to combine like terms. I get 3y minus 32 equals negative 17. I'm going to add 32. And I'm going to get 3y equals 15. I'm going to divide by 3. Y equals 5. Now I know what y is. I'm going to take that and I'm going to put it back into there to get x. X equals 16 minus 5, or x equals 11. Again, I put x comes before y, so my ordered pair, or my solution, is 11, 5. This is my solution, 8, 2 for the first one, and my solution, 11, 5 for the second one. Okay, let's try a third one. 3w minus 2z equals 5. W plus z equals 15. Again, I look at each linear equation. Neither one is solved in terms of a variable by itself, but I'm going to go for my second equation, the w plus z equals 15. That'll be easiest because my coefficients are 1. I'm going to subtract z, and I'm going to get w equals 15 minus z. That's good. I highlight that. W equals 15 minus z, so in the first equation where there's a w, I'm replacing it with 15 minus z. Minus 2z equals 5. You're going to distribute the 3 and get 45 minus 3z minus 2z equals 5. I'm going to combine my like terms. Negative 3z plus negative 2z is negative 5z. Equals 5. I'm going to then subtract 45 to get z by itself, and I'm going to get negative 5z equals negative 40. Divide by negative 5, and z equals 8. That's great. Now I'm going to take what z equals and I'm going to put it back in for w. W equals 15 minus 8, or w equals 7. I write my solution alphabetically. W comes before z, so 7, 8 is my solution. Okay, I want to do 3 more with you, and then I'm going to have you try 2 on your own. There's not going to be enough room on this side, and of course, for you all, so I want you to get another sheet of paper out while I write the next one down, because you're going to probably need more room to do the next couple before you go to the back side. So number 4 is 2a plus 5b equals 16. The second equation is a over 2 plus b over 4 equals 1. So I notice I have fractions in my second equation. I want to get rid of those fractions. How do I do that? By multiplying everything by the LCD, by 4. 2 goes into itself once and into 4 twice, so I get 2a. 4 goes into itself once, so I'm left with 1b, or b, and 1 times 4 is 4. I look at my 2 linear equations. This second one is the easiest one to solve in terms of, because I see that the b has a coefficient of 1. So I get b equals 4 minus 2a. I'm going to take, and wherever I have a b in my first equation, I'm going to replace it with 4 minus 2a. So I get 2a plus 5 times 4 minus 2a equals 16. Distribute your 5 and get 20 minus 10a equals 16. Let's combine like terms. We get negative 8a plus 20 equals 16. We're going to subtract 20 and get negative 8a equals negative 4. Divide by negative 8. A equals 1/2. I'm going to take that 1/2, and where am I going to put that? I'm going to put it back in for b. So I'm going to get b equals 4 minus 2 times 1/2. And 2 times 1/2 is a whole, so b equals 4 minus 1, or b equals 3. So my solution is 1/2 3. 2 more, and then you're going to practice 2 on your own. Number 5. These are a little bit different because they're fractions. So I have 3p minus q, that's a q, over 4 equals p plus 1. My next equation is 5p plus 4. No, not 4. 5p plus q. 5p plus q over 2 equals p. Okay, so the first thing that I think is we should do is again clear the fractions. So in the first one, to clear the fraction, we're going to multiply it each side by 4. When I do that, the 4 is going to go away, and I'm going to get 3p minus q equals 4p plus 4. So that's this new equation. In the second one, I'm going to multiply by 2. The 2's go away, and I get 5p plus q equals 2p. Okay? So in this one, we're going to go ahead and we're going to solve in terms of a variable. So in this case, I'm going to go ahead and solve 5p plus q equals 2p in terms of q. So to do that, I'm going to subtract 5p, and I'm going to get q equals negative 3p. Okay, I'm going to take q equals negative 3p, and I'm going to replace that in for this q in the other equation. You could have, in the blue equation here, got your like terms together first if you wanted to, but I'm going to go ahead and just replace it in first and then move it. So this becomes the 3p that is there minus, instead of q, negative 3p equals 4p plus 4. 2 negatives make a positive, so this is 6p equals 4p plus 4. I'm going to subtract my 4p, and I'm going to get 2p equals 4. Divide by 2, p equals 2. I'm going to take p equals 2. I'm going to plug it in right there for my q. So that's going to give me, let's do it this way. I'm going to plug it in over here. So that's going to give me q equals negative 3 times 2, or q equals negative 6. P comes before q, so it's 2 comma negative 6. Okay, let's try one more together. Let's just in this color, 6. A plus B plus C equals 62. Okay. Let me fix my 62. I don't like how it looks. Then you're given A equals 2C minus 5. And you're given B equals 3C minus 5. So in this case, I'm going to go ahead and I'm going to replace A with 2c minus 5, and I'm going to replace b with 3c minus 5. So when I go to do that, My A is going to come here. My B is going to go there. So instead of A, I'm going to write 2